right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is solving rational equations 2, as in there was a 1, and just like the Matrix trilogy, the second movie is going to have a lot more action in it than the first. So if you didn't see that last video, that was the last one in this series that I did, and that one is in the playlist, which is at the end of the video, and sometimes I put it in the link in the description, so go check that out if you want something a little lighter than this. It's not going to start out crazy, but it's going to get a little crazy by the end. So you've been fairly warned that this one is the harder version of the two. All right, so let's go ahead and jump in. So just like from the last video, we were talking about how you don't have to necessarily find the LCM, the least common multiple. So least common multiple. And sometimes we call it least common denominator. I like least common multiple. I don't know why. I guess I just feel like it rolls off the tongue better. You don't necessarily have to try to find that, okay? So I'm not going to teach you how to find the LCM in this video. It's not really that important to find it. Normally, when you just multiply by whatever the biggest thing is, that happens to be the LCM, and if it's not, you can just, do it anyways, and then multiply by something else. So it's not super important to find the LCM. Let's go ahead and just multiply this by the biggest thing. And by the biggest thing, I mean the largest denominator. The largest denominator is 4k. Okay, and I'm using that word largest a little bit relatively here because we don't know what k is, right? So it has the most things, right? So generally speaking, that's what we're looking for. Which thing has the most things in it? In the bottom denominator. So when I put this parentheses like this is also not super technical. If you are coming across this video for the first time, I don't do things super technical. So if you're like, oh, you can't put the parentheses like that, please let me know in the comments because all content is good content. So you're welcome to tell me how I'm doing something wrong in the comments. But I don't care to do things the like mathematically accurate way. I think when I do stuff, you'll understand what I mean. And if you don't, let me know in the comments and I'll fix it for another video and make it a little more understandable for you. But this basically just means I'm going to distribute the 4k into everything. So let's go ahead and do that. So the 4's here would cancel and I'd have k left over. 4 cancels with that 4. I'd have k left over and then I'd have to distribute that k. All right, so then it's going to happen again. The 4's and the 4 cancels. I have k and I have to distribute another k. And then over here, the 4k's completely cancel. And I'll go ahead and just slash it since that's the last one there. So then there's nothing to distribute. So it's just k plus 4. Whew, all right. So now we need to do a little cleanup here. We need to distribute that k. So k squared plus 4k plus k squared minus k equals k plus 4. Oh, I put k plus k. I said 4 and I wrote k. So now we have distributed. We needed to distribute just to clean things up a little bit. And now we can start to decide how we want to solve it. Now that we have a little bit of combining stuff to do, but we can now decide how we want to solve this. And we're going to have to solve it using factoring because there's a k squared and a k. So there's no way to just solve it using standard solving, which is SADMEG or SADMEP. And if you're not familiar with those terms, I have videos on those as well. I'll probably have that be my recommended video at the end. So you're welcome to scroll ahead to the end and grab that. I usually don't put things in the description as much as I probably should. But it's at the end of the video. I always do that. So k squared plus k squared is 2k squared. 4k minus k is 3k. So that and that. K plus 4. So the goal here, now that I know I have to factor to solve, is to move everything to one side. And by move, I mean, like, obey the laws of the equation to move it. So subtract k on both sides, subtract 4 on both sides, 2k squared plus 2k minus 4 equals 0. Whew, man, this is taking up a lot of space. All right, we're going to have to cut into the space for number 2 here a little bit. So now that we have this, we can actually, there's actually a greatest common factor here of 2. So we can actually divide out that 2. Sometimes you just factor out a greatest common factor, but here we can just divide it because it's equal to 0. So we're going to divide everything by 2. So then we get k squared plus k minus 2 equals 0. And then we just have to normal factor that. Now that there's no number in front of k squared, aka it's a number 1, but you know what I mean. There's no number in front of k squared, no visible number. That's a good thing. That means that the factoring isn't going to be as crazy, right? And I have a feeling we're going to have to do some crazy factoring towards the end, so I'll probably start writing a little smaller to be able to fit all this in here. I just realized I was writing kind of big because I wasn't zoomed in, but now I'm zoomed in. So we want two things that multiply to 2, and shocker, there's only two things, 1 times 2. And I need those things to multiply to negative 2 and simultaneously add or subtract to positive 1, the number in front of k. So negative 1 and positive 2 add to 1, and they multiply to negative 2, so those are my factors. Equal to 0. Anytime you're doing regular factoring, you don't really have to try to solve what's in the parentheses. You just take the opposite of the number. If you're doing what I like to call extended factoring, like when it's 2k squared, blah, 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 and you can't take out a GCF, then you might want to be careful solving for the things. But here, it's just k minus 1 and k plus 2, so we'd have to, add 1 to both sides, so k is 1. And then we'd have to subtract 2 on both sides, so k is negative 2. And those are my answers. And those answers work out just fine because if I plug them back in, they all, work out. If there are square roots or denominators, you want to be careful to make sure that when you plug it back in, it doesn't cause problems. But with these kinds of questions, since they have denominators with a variable in them, you really just have to plug it back into the denominator and make sure it doesn't give you 0 in the denominator. Because if it does, then that's what's called an extraneous solution, which just means that it's, not a real solution. And they said here, remember to check for extraneous solutions. So what that means is plug it back into the denominator, and if it equals 0, like the denominator, that is, if the denominator equals 0 of any of the denominators, then that's a problem. Eliminate that answer and just keep the other one that works. So that's what they mean by extraneous. Okay. And it's kind of weird. I don't really know why extraneous solutions are the way they are, because you didn't do any math wrong, but yet you got it wrong. So honestly, it's kind of a mystery to me. So if you know the reason why, I'd be happy to know in the comments why that is. Why do extraneous solutions even exist? Why can't we just get it right the first time? I'm going to multiply this number 2 onto number 2 now. I'm going to multiply the whole thing by 2m squared. I kind of had to squeeze it in there, but that's what that is, 2m squared. So that completely cancels with this, and I just have 1. Then just some m's cancel here. So I'd have 2m left over, 2m squared divided by m. I'd have 2m left over. And I'm timesing it by 1, so, just 2m. Minus, here the 2's cancel, and the m squared would be left over. Okay? So we want to get everything on one side. It would be less work to get the 1 and move it to the right-hand side. But I'm actually going to move everything to the left-hand side because then that way m squared is positive. If it's negative, like negative m squared, like right now it is, then technically you'd have to do the extended factoring. You wouldn't be able to do normal factoring. And that's a bummer because normal factoring is much less work. And I like much less work. I'd rather work smarter than harder. So that's what we're going to do. We're going to move m squared over. We're going to add it. Boom, boom. 2m minus minus. So that's going to come over here too. 2m. I'm squeezing it all in here because I'm going to need this room for later. I need to start practicing writing small here because there's a lot of steps and I have to squeeze it all in. Now, if you were doing this as an assignment, I would highly recommend just getting a separate sheet of paper for this. But I am not that wise. I'm going to try to fit it all in here. And besides, I can't just whip out a separate sheet of paper. Come on, I'd have to switch back and forth between screens, and that would be annoying for you. So, for your sake, we're just going to try to fit it all in here. Minus 1 minus 1. Negative 1 times negative 1 is positive 1, and negative 1 plus negative 1 is negative 2. So those are my factors. And since they're the same exact factor, there's only one answer. M equals 1. And if I plug that back into the denominators, it does not make any of the denominators 0. Therefore, we can keep it. Like that puppy at the puppy dog store. You can keep him. You have my permission. All right, so moving on to the next one. I'm going to go a little bit faster as we go, as long as we're not running into anything new. So I always spend a little bit of extra time on numbers 1 and 2 just because it's the beginning of the worksheet. We're talking about how to do it, and you might be a little confused. So, there's that. But as we go along, unless we run into something new, I won't explain it as much. I'll start, talking less and less as we go through and just kind of solve it. Okay. Number 3 is a little bit different in that I just multiplied everything by 2n squared, which happens to be the LCM. If you have trouble finding the LCM, I've already said it, but I'm going to say it again. If you have trouble finding it, no big deal. If you wanted to multiply everything by n squared, that's fine. You'd get all the n stuff to go away, and then you'd still have the n minus 6 divided by 2 thing over on the right-hand side of the equation, and then just multiply everything by 2 afterwards if you really want to get rid of all the denominators. So you can totally do that. You can multiply the whole equation by n squared and then 2 separately. That's fine. Eventually you'll get it all in there. And if your tests are not timed, then I wouldn't worry about it too much. If you have a timed test and you feel like you're on a time crunch, you might want to try to find the LCM. But other than that, not that important. Okay, so anyways, the n squareds cancel. N squareds would cancel, so I'd have 2, but I need to distribute that 2. So 2 n squared minus 6 minus n. Sorry, n squared minus n minus 6. Whew. Some dyslexia there for a second. 2n squared and n. The n's would cancel. I'd have 1 n still. 2n squared cancels with n. There'd be 1 n left over, so it'd be 2n. 2n. And I have to distribute that. Okay. And then over here, 2n squared and 2n. So there'd be an n left over, and that's it. N minus 6. All right. So there's a lot to do here, and actually there's a bit of n squared minus n minus 6 factors. And 2n plus 12 has a greatest common factor. I'm wondering if I can do something with that. I don't think I can. It doesn't look like I can. Because that would be minus 3 plus 2, and that'd be a plus 6 and a minus 6. Yeah, it doesn't look like I can do anything with that. So I'm going to have to distribute. I was trying to think of some fancy way to solve it, but I don't think there's a fancy way. If you find the fancy way to solve this, let me know. It almost seems like there should be. But maybe that's just because I do a lot of SAT tutoring. And the SAT has a ton of like little tricks in it where you can find a shortcut route. Kind of like in Mario Kart. That shortcut route. You know, that little shortcut that like sometimes it's kind of easy to find, and then other times it's like, oh man, I don't know if I even want to try to take this shortcut unless I, catch a mushroom at just the right time. If you don't catch that reference, I'm sorry. Sorry, not sorry. 2n squared minus 4n squared is negative 2n squared. Okay, I like to cross them out as I go just so I make sure I don't miss any. Minus 2n minus 24n, so minus 26n. And minus 12. Okay, so that's all the simplifying there is to do. And again, with all of these questions, it seems like we're going to have to factor to solve them. But if you don't have more than one kind of variable, you don't have to factor. Even if it's like x squared or something. If it's just x squared and there's no x, you can still just solve that without having to factor. So keep that in mind. I'm going to move everything on the right-hand side just because I like my leading term to be positive. I'm still going to have to factor using extended factoring, it looks like. Well, maybe not. Let's find out. So let's, we want to add 2n squared to both sides. Add 2n squared to both sides. Then we want to add 26n to both sides. And then we want to add 12 to both sides. Okay, so we get this. And I thought we were going to have a greatest common factor, but it looks like we don't, and I'm kind of sad about that, but, you know, it is what it is. So we're going to have to do a special kind of factoring. And this is a kind of factoring that I'll probably do a whole series on eventually. And I like to call it two truths and a lie. I have a whole video on this. Maybe I will put a few extra videos in the description below. But it's called two truths and a lie. What you do is you multiply the first two numbers. Then you find factors that give you 20. So let's see, 3 and 12 aren't going to work. 4 and 9, what's next? 6 and 6. No, that's not going to work. So it exists because if I do 3, 2, 2, oh, 2 and 18. There we go, found it. Okay, 2 and 18. So they add to 20 and they multiply to 36. Then what you do is you create two 3n's. And then you divide out the lie. So the lie is the one that has a greatest common factor. 3n plus 2, no greatest common factor. 3n plus 18 does have a greatest common factor of 3, but it shouldn't. So it's a lie. We divide out the lie. It exposes the truth. Exposed. And then we get the fully factored thing. So if you've never seen this kind of factoring before and your mind is like currently blown, first of all, you're welcome. This is like the fastest way to factor these sorts of things. Like there is no faster way to factor these. Like there is no method that exists that's faster than this. I dare you to find one. And also it's fun because it's a trick. And also I like it because I came up with a cool name for it. I didn't discover it. I won't take the credit for that. But I did come up with a cool name for it. When we do 3n plus 2, we have to solve that by, SADMEP, doing the opposite of the order of operations. So we would subtract 2 to both sides, and then we would divide by 3, so negative 2/3. Whew. All right. That was a little cray-cray. I kind of want to check this one because this is the first one that's been a little cray-cray, and I want to check to make sure we have the right answer. Plus, it dipped down into number 5, so I'm going to have to be even more careful with number 5, but I kind of want to check this one. And you can too, on your own, actually. This one is called Solving Rational Equations 2. You can literally just Google this, and it comes up with this exact document that I'm looking at right here. And check it out. Boom, there's the answers. Negative 2/3 and negative 6. Negative 2/3 and negative 6. So we did get it right. Look at that. Cool. All right, so, and I don't feel bad about looking up the answers because when you're trying to learn something for the first time, and remember, when I'm doing this, I'm like trying to like pretend a little bit like I'm solving it like a student would. So I like to kind of play that line a little bit, but you're more than welcome. I don't have any trouble with looking up the answers. I think copying the answers and not learning anything is detrimental. But knowing the answers is, I think, really helpful because then you can make sure you're on the right track. I mean, if you're learning something for the first time, you're not going to be like doing it all completely right off the bat. It's a new thing, right? You're going to make mistakes. It's okay. Anyways, let me get off my soapbox. X squared, that cancels. This would be 2. We need to distribute that 2. 3x squared plus 24x plus 48. 2x squared cancels. So we have plus 6 minus 8 equals the x squareds cancel, and it'd have 2 times 1 is 2. All right, so we need to distribute this. This is going to be 6x squared plus 40. Oh, I said 40, but I wrote 20. 48x plus 96 plus x minus 6 equals 2. All of this is equal to 2. That's so funny. All right, we want to subtract 2 to get it equal to 0. We also want to combine those x's there, so 6x squared plus 49x. Oh, and 96. 96 minus 6 is 90, minus 2 is 88. All right, so I just did like a bunch of things all at once there, but forgive me. Yeah, okay, so we're good. 49 is 7 times 7, so there's no greatest common factor to try to pull out first. Unfortunately, this is going to be really gnarly, but, it is what it is. 6 times 88. Goodness gracious. Okay, so that's 48. 4, 48, and 4 is 52. Okay, cool. 528. At least it should be. Let me just check my math. Make sure my mental math is still on point, and I'm not going senile over here. Yeah, 528. Okay, I still got it. All right, so 6 times 88 is 528. It just didn't look like it divided by 11, right? Like 528, how would you know that divides by 11? Anyways, we want to get factors of 528. This is laughable. That gives us 49. Okay, so let's start with 8 maybe. Let's try 8 because I know it divides by 8 since 528 is 6 times 88. It has all the factors of 6 and 88, so it will divide by 8. Let's see what that is. 66. Okay, not those factors are not close enough together. So what I'm trying to do is I started with the fact that I just multiplied by 6 and 88 to get 528. 6 plus 88 is going to be too big to be 49. When the factors are closer together, all right, when the factors are closer together, they'll add to a smaller number. When the factors are further apart, they add to a larger number. We want to add to a smaller number, so we want the factors to be pretty close. So let's try 11. We know it divides by 11 because I just multiplied 88 by something. So let's divide by 11. Oh, 48. We're pretty close. 48 plus 11 would not be 49, but we're getting there. We're getting there. Maybe 12. It would go into 12. And if you're not sure, you could always just do it. Just do it. 12 and 44. Okay, we're almost there. 528. I don't think it divides by 13. 14, 15, 15? No, it doesn't go into 5. 16. Let's try 16. Hey, 33. Does that work? 16 plus 33 is 49. Yeah, there we go. So 528, if I divide by 16, is 33. 16 times 33 is 528. 16 plus 33 is 49. Goodness gracious, that was crazy. And it's only going to get worse from here, folks. No wonder you Googled this worksheet and you were like, oh my gosh, what is going on? My teacher is like trying to kill me. Yes, they are. But I am here to save you. Okay, so let's... Oh, that doesn't divide by 6. That does not divide by 6. That divides by 3. This divides by 2. So my method is called two truths and a lie. Usually if you have two factors, here's what happens. You either have one true factor and one false factor, which we had in number 3. Or in this case, we had two false factors. Okay, so it's called two truths and a lie because of the icebreaker, two truths and a lie. But it's actually more like all lies. Like you're very likely, well, not very likely, but you're likely to have at least one lie, if not both of them being lies. So it's just called that based on the icebreaker, two truths and a lie. But let's divide out the lies. All right, so you divide out those GCFs. 6x and 16 both divide by 2, so I get 3x plus 8 and 2x plus 11. All right, and you can check to make sure it multiplies back out. 3x times 2x is 6x squared. 8 times 11 is 88. And you can do the middle stuff if you want to, but I'm telling you, this method works. It absolutely works. And one thing I didn't show you because I had a lot of space that I was already using up on number 3 is I didn't show you the actual solving part. I'd like to show you that, at least for this one. You set each one equal to 0. So when you have something in front of x, you have to be a little bit careful solving because it's a two-step equation. So we're going to subtract 8 from both sides here and then divide both sides by 3. Negative 8/3. And then over here we're going to subtract 11 on both sides. And then divide by 2. So we get some gnarly numbers. But that's kind of to be expected because this was a gnarly problem. Let's check to make sure we got that right. Negative 8/3 and negative 11 halves. We did. All right, cool. So negative 2 and 1 and 1 so far. I forgot to check 1 and 2. Yeah, we got them. Number 1 and number 2 were not nearly as difficult as 3 and 4. Let's see if things get worse or better with numbers 5 and 6. Number 6 doesn't look bad. It's got Not a lot going on there. Maybe there's some hope after all. Let's find out. All right, so we're going to multiply both sides by 3k squared. This is going to be pretty much the same as before. The 3k squareds cancel completely here, so I have nothing to distribute. K squared plus 2k minus 8 equals 3k squareds cancel completely again, and I just have 1 left over. And then here, the k squared cancel, so I just have 3 times 1 is 3. All right, so then I have, let's, k squared minus 8 equals 4. We want to subtract 4 on both sides. K squared plus 2k minus 12 equals 0. Yeah, this is not nearly as bad. I feel like normally it gets worse as you go, but we're getting a reprieve here, at least for now. 3 and 4, 6 and 2. What am I? Ooh, wait, hold on. Do we not have factors that work? That's 4. We subtract 4. It was already minus 8. Subtract 4, we get negative 12. We want 2. Am I just missing something here? Hold on. If we do 3 and 4, we would get 1 when we subtract. If we did 6 and 2, then we would get 4 when we subtract. So that does not factor. At least not, using this method where we try to think of integer factors. It looks like integer factors are not going to work. That doesn't mean that we don't have an answer. It just means that the answer probably isn't going to be very nice. So at this point, we can either do completing the square, which I'm not a huge fan of, but we could do. Or we could just do the quadratic formula and get the answer that way. By the way, I have an awesome program called, what is it called? Called vertxint. You're limited to 8 characters when you name your programs. So since you're limited to 8 characters when you name your programs, I call it vertxint. Finds the vertex and the x-intercepts of a quadratic function. That's essentially what we have here, is a quadratic function. So I just launched the program. I hit 1, being extra lazy, 2, and negative 12. 1 is the number in front of k squared. 2 is the number in front of k. Negative 12 is the number that's by itself. And it looks like we do have some factors. We get 2.6 blah, 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 and negative 4.6 blah, blah, blah. So it looks like we do have some factors there. I wonder, is it going to give us the decimal approximations for 5? It says negative 2 and 4. Hold on. I must have done something wrong for number 5. Maybe it was deceptively easy, but actually I messed up something. Let's see here. Oh, I did mess up something. 3k's cubed. 3k cubed, not squared. I did not catch that. They haven't done that yet. I was not ready. I was hashtag not ready for that k cubed. Oh my gosh. As you can probably tell, this is the first take of this video, and I don't do second takes, so we're just going to fix this. 3k cubed. It happens to everyone. All right, so that was actually k squared plus 2k minus 8, because that cancels out completely there. But then over here, the other side of the equation is not going to be like how I initially wrote it out to be. So let's take a look-see, shall we? So actually, let's get rid of this right here. And that should be all we have to erase to do this here. So let's go ahead and take a look-see at what we have here. 3k cubed, not squared, 3k cubed divided by 3k squared, there would be a k left over. So we have k. And then this was just k squared by itself, I think. Yeah, k squared by itself. So the k squared and the k cubed would cancel. We'd have 1k left over, so it'd be 3k. So k plus 3k. So that's 4k. And then we subtract 4k on both sides. So we'd have negative 2k minus 8 equals 0. All right. That's a lot easier to factor. Whew. So number 5 was deceptively tricky. I was not ready for that. 4 times 2 is 8. Negative 4 plus 2 is negative 2. K there, equals 0. So k is equal to 4 and negative 2. All right, that's a lot nicer. k could not have been equal to 0, by the way, because of the denominator, but there were no 0 answers, so no extraneous solutions. All right, moving on to number 6. Hopefully there's no deceptively simple trick to this. It looks pretty easy compared to, number 3 and number 4, so let's find out. 3k divided by 3 is k times k is k squared. 3k divided by 3k cancels completely, so I just have minus 1. And then 3k divided by k is going to be 3, so that's just 3. This is... Wow, really? That's it? K equals 4? No way. Really? That's it? Number 6 is 4? Wait, hold on. I did something wrong again. What am I doing? They say it's negative 2 and 2. Hold the phone. Let's see here. So 3k minus 1. What did I do wrong this time? Oh, k squared. I'm an idiot. I'm sorry, guys. There we go. Okay, so we don't have to factor still, though, even though it's a k squared, because it's only one kind of k. So then you would just say, okay, this is just plus or minus 2. Plus or minus 2. Man, I am not seeing stuff today. I apologize. Like, not on my A game. I'm going to blame it on being really tired. It's been really rainy in Florida, but I feel like it's always rainy in Florida. But, like, really, though, it's been, like, really rainy in Florida. Thunderstorms and all that. So I'm going to blame it on that, and we'll just go with that. That's my excuse. All right. But from here on out, do it the right way the first time. So let's check this out. 6x, 6x, that cancels. X minus 4. 6x and 6x cancel again. We have x squared minus 3x minus 10. Then the 6's cancel and we have x. We have to distribute that x. And there we go. All right, let's combine like terms. X squared minus 2x. And that's a minus 10 minus 4, so minus 14. Distribute that x. X squared minus x. The x squareds cancel. And we want to add x to both sides. Actually, you know what? No, let's add 2x to both sides, because then that would just be x equals negative 14. Boom. X equals negative 14. There should be only one answer, assuming I'm not missing something again. I swear, if I have missed one more thing, I'm probably going to just end the video early. All right, there we go. So negative 14. Got it. All right, so let's go ahead and move on to 8. Nothing really that new, so we're just kind of doing stuff that we've already been doing. X squared cancel, that's just 1. X squared divided by x is x times the quantity x minus 1. X squared divided by x is x. X times 1 is x. Okay. X squared minus x plus x. Oh, excuse me. Minus x plus x. Oh, that cancels. And we have x squared equals 1, so we take the square root. Square root. Oh, what did I write? Square root again. I didn't need to do that. There's the answers. X is plus or minus 1. Let's check. Did we get that right? Plus or minus 1. Hey, look at that. That's the thing, is whenever you get one kind of variable, you don't have to factor. You can just go straight into solving. Just remember that when you take a square root of both sides of an equation, you have to plus or minus it. Don't forget that if you're going to not factor. If you think you'll forget, or if you have forgotten in the past, then it could be more helpful to factor it even though you don't need to. But if you can remember to do plus or minus when you take the square root of both sides, I would recommend doing that, because standard solving is easier than factor solving. So here we go. R plus 3 and R minus 2 have nothing in common. I know it seems like they do because they both have R's, but they don't. Because R plus 3 is one number, R minus 2 is one number. And since we don't know what R is, we don't know for sure if the number R plus 3 would have anything in common with the number R minus 2. It could. It's possible. Like if R was 7, right? If R was 7, let's say, R plus 3 is 10, R minus 7 minus 2 is 5, so then 10 and 5 would both have 5 in common. So it's possible, but it doesn't have to. They don't have to have something in common because it's r plus 3 and r minus 2, which is one number. So you have to remember when you're doing these, if you have two different things, like binomials, the little, two things separated by a plus or a comment or plus or a minus, then you have to treat them as two totally different things because they are. And you just got to roll with it. So we're going to multiply both sides by r plus 3 and r minus 2. R plus 3, r minus 2. We have to multiply by both if we want all of the denominators to go away, which we do. So then we have r plus 3's cancel, and we have r minus 2. Then r minus 2's cancel, and we have r plus 3 times r plus 4. Everything has to stay in a parentheses. We're distributing the quantity r plus 3 into the quantity r plus 4. Sounds kind of crazy when you say it like that, but we have to keep everything wrapped up in parentheses unless, like over here, r minus 2, that didn't have a parentheses because there was nothing to multiply by. All right, r minus 2's cancel again, and we have 6 and r plus 3. All right, I put the 6 first just because it looks better. You could have put r plus 3 and then put a dot and then a 6, and that would be the same thing, okay? Order does not matter when you're multiplying. All right, let's FOIL. First times a first. Outers and inners, so 4r and 3r make 7r. All right, outers is 4r, inners is 3r, 4r plus 3r, 7r. I'm kind of skipping a few steps here, but it's just because I know I'm going to maybe have to squeeze in some stuff when I get towards the end here. So I'm trying to be a little conservative on the space. And then 3 times 4 is 12. Plus 6r plus 18. R minus 2 equals r squared. We've got 7r plus 6r is 13r. 13r. 12 plus 18 is 30. Then we want to get everything over to the right-hand side. So we want to subtract r on both sides. And we want to add 2 to both sides. All right, 32 is 8 times 4. So 8 and 4 multiplied to 32, they add to 12. Boom, 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 boom. So we have our answers. R equals -8 and -4. And can we plug those both in? Yeah. The only numbers we couldn't plug in into the denominator would be -3 and +2. So those numbers we can't plug in. We can plug in -4 because it does make that one thing negative, that r plus 4 thing, but it makes it 0. But it is okay to make the numerator 0 because if the numerator is 0, 0 divided by anything is 0. But anything divided by 0 is nothing. Seems kind of weird when you say it like that, but that's true. Anything divided by 0 is nothing, and 0 divided by anything is 0. And my computer is yelling at me to plug it in. Hold on. We'll be back after these messages. All right, and we're back. So -8 and -4. I kind of want to plug it in real quick just to see what happens. -4, that is. So if we plug in -4, we get -1 is equal to, and then all that would go to 0, and then -4, -6. Yeah, -1. Oh yeah, it works. Okay, cool. So yeah, -8, -4. Okay, it only has to not equal 0 in the denominator. Okay, number 10 is a new thing. Number 10 is a new thing because it's not factored, and it looks like if I factor it, I could end up with, something that could be helpful here. 25 is 5 times 5. We need to have those 5s add to -10, though. -5 times -5 is still positive 25, but now they add to -10. So it looks like if we multiply both sides by a minus 5 squared, then it'll get rid of everything because everything is made up of a minus 5s. I couldn't just multiply everything by a minus 5 because it would get rid of only one of the a minus 5s on the left-hand side of the equals. I need to get rid of both, so I have to have 2 of them. Okay, so it would cancel completely on the left-hand side, and I would have a squared minus 4a minus 12. then only one of the a minus 5s cancels with these. So I have to distribute an a minus 5. So 6, a minus 5, and a minus 3, a minus 5. All right, so we got a little bit of work to do. Don't really have any work to do on the left-hand side. We're just going to copy that. Can't do anything with that just yet. We can try to factor it, but why? We just have to unfactor it because we need to get everything all together before we factor. So then 6a minus 30 plus, we're going to FOIL, first times a first, outers and inners. Outers is negative 5a, inners is negative 3a, which makes negative 8a, and the last is 15. All right, and actually, a squareds cancel. We've got an a squared on both sides, so that's cool. Now we don't have to factor anymore. We just, get all the a stuff on the left and all the not a stuff on the right, or vice versa. Looks like we'll want to get all the a stuff on the. Well, actually, no. Let's do some more cleaning up. Let's do some more cleaning up first. So negative 4a minus 12 equals 6a minus 8a is negative 2a. Negative 30 plus 15 is negative 15. And I believe that's everything. And then actually it's going to be easier if we add 4a. Because remember, I like to keep things positive. You don't have to do this. This is my preference. I like to keep the leading term positive. It's just a personal preference of mine, really. But you don't have to. If you prefer to have the variable on the left-hand side, even if it's negative, then go for it. It takes literally the same amount of steps, usually. Sometimes my way is faster. If you prefer to have your variable on the left-hand side, it sometimes will take one extra step. And maybe that's why I prefer to do it that way. If you keep the leading term positive, sometimes you can save yourself a step. But not in this case. We add 4a to both sides, we get 2a. Positive 2a. If we add 15 to both sides, then we would get 3. So a is equal to 3 halves. And that should be fine. Let me just check these answers, because 3 halves, I know we're supposed to get fraction answers for some of these, but these are hard problems. I want to make sure I'm getting the answers right here. 9 and 10. Negative 8, negative 4, and 3 halves. Okay, cool. We're still on the right track. And we're more than halfway done. We've only got a few more. 6 to be exact. And then we're done. All right. Let's move on to the next set here. It looks like we just have an n plus 3. There's 2 of them, but not 2 of them in the same denominator. So I can just multiply by n plus 3 and it'll be all right. So it'll cancel completely with this and this. And I'll have 1 plus n squared plus xn plus 5 equals, I do still have to multiply that n plus 3 over here as well. So that still has to happen. But the n plus 3's cancel completely on the left-hand side. All right, so let's go ahead and combine like terms. N squared plus xn plus 6 equals n squared. The outer terms and the inner terms cancel, actually. Minus 3n plus 3n. Because these are what's called conjugates, so the middle terms always cancel. So n squared minus 9. N squareds cancel, so I'm only going to have one answer again. Let's get rid of the 6. So I have the space for it. We'll go ahead and show that in between step. 6n equals negative 15. Divide by 6. And that's going to simplify to, oh my gosh, math. 5 halves. There we go. Negative 5 halves. And that works because the only denominator is n plus 3. So only negative 3 would not have worked. Negative 5 halves, folks. All right, 12. 4x. All right, multiply that on everything. 4x divided by 2 is 2x. 2x times 1 is 2x. 4x divided by 4x cancels completely, so I just have the numerator. 4x divided by 2x is 2. 2 times 1 is, well, 2. And there we go. Let's get everything on one side. Because I'm not going to have x squareds cancel, I have an x squared and an x, so I'm going to have to factor. So we want to subtract 2x on both sides. Minus 9x. 10 minus 2 is 8. 8 is 8 and 1. Negative, negative. So that way I can subtract or add the two negatives and get 9. Negative 9, that is. And then we're done. We get 8 and 1. And it looks like both of those answers will work. All right, let's check. Negative 5 halves, 1 and 8. Negative 5 halves, 1 and 8. All right, we're good. We're on to the last 4 here. I'm waiting for the extraneous solution. That's why I keep checking them, because I'm like, what if I'm missing something? But there's going to be an extraneous solution, right? Because I'm going to scroll back. It says, remember to check for extraneous solution. So I've been checking, and there hasn't been one yet. So I'm like waiting for it. It's like, because you know it's going to happen. You don't know when. Let's go ahead and factor this. If it can be factored, if a denominator can be factored, you want to factor it. So that way you can tell, you can help to find out what your LCM is. Okay, so this is k plus 1 times k. So if we just multiply everything by k plus 1, that'll get rid of all the denominators. All right, k plus 1 divided by k is k plus 1. Times 1 is just, k plus 1. Equals 5 times k plus 1. Well, k plus 1 is k squared plus k, so this is 5k squared plus 5k. I'm going to just go ahead and distribute that 5. And then the k squared plus 1 thing completely cancels there for that last term, and I just get 1 on the top. All right, so k squared and k, we're going to have to factor this. So we want to get everything on one side. 5k squared. We would subtract k on both sides. So 4k. And subtract 1. Oh, hey, actually, this is not going to be so bad because the 1's cancel. So now all I have to do is just take out a greatest common factor. Yeah, that actually wasn't so bad at all. All right, so then k is 0, and 5k minus 4 is equal to 0. 5k plus 4, I mean. So then 5k equals negative 4. K equals negative 4/5. And 0. And actually, we have our first extraneous solution. It looks like 0 should be an answer, but if you plug it back in, you get 0 for the denominator. This is our extraneous solution. There it is. It's extraneous. So that means that we didn't do anything wrong with the math. It's possible that I could have done something wrong again with the math. But I feel like I've redeemed myself since numbers 5 and 6. So we did all the math right, and you can check it if you want. And we get 2 answers. But one of the answers just doesn't work when we plug it back in. And again, this is a great mystery to me, why this is even a thing. But it is. It doesn't work when we plug it back in. We get 0 for a denominator, so it's no good. It's extraneous. Whew, all right, there was our first one. Now, there could be more, but that was our first one. So let's go ahead and factor this. P minus 4. So this is going to be P minus 4, because that'll get rid of the P over here. So that cancels completely, and we just have 1 plus, and then 1, just a 1 by itself, so that's P minus 4, so P squared minus 4P. And then here, P's cancel, and I have P minus 4 times P minus 6. So I'm going to have to FOIL that out. Let's reorder these so that they're in order from greatest to least. And then over here we have P squared minus 6P minus 4P, so minus 10P plus 24. Then, oh hey, P squared. Look at that. P squareds cancel. I like it when that happens because that means we don't have to factor. Not having to factor means less work, and less work is great. So, and it also means we have room to show a little bit more steps. So let's add this. Okay. And let's subtract that. So then we get 6P equals 23. Ugh. That does not divide well. Gross. Is it really 23 over 6? Really? Really? It's 23 over 6. That's such an ugly number. Let's check it. So we should have gotten negative 4/5 and 23 over 6. Negative 4/5 and yeah. Okay, those were the answers. Okay, that's weird, but it is what it is. Right? It is what it is. And I'm not that surprised that we're getting weird fractions because we've been getting weird fractions. This is the thing is if your teacher is normally kind of nice on tests and they give you like nice answers and stuff, and then all of a sudden you get like a weird fraction out of nowhere, and the whole rest of the test has been all like -5, +3, -12, then that would be, I think, a red flag. But if you've normally been getting like a fraction here and there, and then you end up with a fraction for an answer, that's not a red flag. It's just sort of like, hey, you got another fraction, right? So look for patterns, um, but we've been getting fraction answers, so no surprises there. Greatest common factor here of n squared, so we have n minus 2. And then right here, n squared again, n minus 2. It's the exact same thing, n cubed minus 2n squared. So yeah, that's the LCM, n squared, n minus 2. So we multiply everything by that. N squared divided by n is n, so we'd have n times n minus 2 times 5 minus, then for the other two terms, everything cancels completely in the denominator, so we're just left with what's in the numerator. So that's actually pretty nice. So minus 6 equals n squared plus 5n minus 6. Then we need to distribute. Actually, let's rewrite this. 5n n minus 2 minus 6 equals n squared plus 5n minus 6. So then we distribute 5n squared. You don't have to do it this way, but I thought it would make more sense. 2 squared plus 5n minus 6. And let's get everything on the left-hand side because we have an n squared thing here. So we want to subtract n squared. We want to subtract 5n. And, oh, the 6's cancel. Oh, that's so nice. It's so nice when things cancel because it means you have less work to do. So canceling things is great. So then we just have to take out the greatest common factor, and that looks like that's just going to be n, 4n minus 15. So n equals 0. And I'm just going to do some quick maths here. I'd have to add 15 both sides and divide by 4, so it's 15 fourths. All right. 1, because we kind of ran out of space, and 2, because we're at the last two problems of the worksheet. So I think, you know, if you've been able to follow since up to now, then you've probably, you know, can solve a two-step equation without too much trouble. And last one here, x minus 3. So as we're working on this last one here, I forgot to mention this at the beginning. Normally I only mention it at the end anyways, but I have a little like PDF guide. I call it the 5 math mistakes everyone makes and how to avoid them. It's a pretty handy little guide I put together that just shows you like, hey, like if I'm, you know, making this mistake, how can I stop myself in the future from making this mistake so that I can, you know, start getting math problems right. So it's a little guide, and the ultimate goal of the guide is to just make sure you get your math problems right. So it's a free guide, made it for you, and you can grab it for free on my website, myersmathematics.com. That link will be in the description below. Other links, not always, but that one is always down there in every video. So you can go check that out at your leisure. And let me know what you think about it. Let me know if that guide is helpful. All right, I'm going to have to put a parentheses around this last one here because even though I'm not really distributing anything, I kind of am because there's a negative sign. You have to be really careful with negatives. Spoiler alert, the #1 math mistake that people make out of the 5 is negatives. That's the first one on the list on that PDF. Because they are. Negatives are crazy, man. They can take a Calculus 3 student and make a fool of him. So let's go ahead and distribute everything. X squared. That's 2x and minus 3x is minus x. And then minus 6. Do the same thing here. X squared. And then that's going to be minus 3x minus 1x, so minus 4x. Plus 3. Minus 4x minus 2. All right. And good news. X squareds cancel again. Yay! Always good when that happens. Let's clean up the right-hand side a little bit before we start combining stuff. So negative 8x and plus 1. All right, got it all. And now we let's add 8x to both sides. So plus 8x plus 8x. So we get 7x. And then let's add 6 to both sides while we're at it. Oh, we're going to end on a nice note. This is going to be a nice answer for once. Look at that. 7 divided by 7 is 1. Final answer. Lock it in. The final answer was 1. I feel like they did it on purpose. Let's look. So, oh, wait. Did I cancel out the 0? I did not cancel out the 0 is extraneous. Whew. I almost left out an extraneous answer there. Zeros don't have to be extraneous, but they are probably the most likely number to be an extraneous solution. So heads up on that. If you get 0 for an answer, it doesn't necessarily mean it's extraneous, but you better plug it in. I mean, you should plug in all the answers to make sure they're extraneous. But if you don't, for some reason, at least like make sure zeros go in there. Yeah. So number 15 was 15/4, and number 16 was 1. Hey, look, we got it. So at the end of every video, I like to just kind of scroll and recap. So the whole point of solving these equations is to find the LCM. If you need to factor, you need to factor. And as you go, you get the answers. You usually get 2 answers, sometimes only 1, but usually 2, at least in this worksheet. We got 2 answers pretty much every time. And not all of those answers we're going to keep, because if you plug them back in and they make the denominator equal to 0, then those are called extraneous solutions, and you have to cross them out because they are no good. All right, so that is what this video was all about. If you would like this particular worksheet with all the work on it and everything, just let me know in the comments below. Or you can just shoot me an email and be like, hey, I'd like that worksheet with all the answers on it. I keep all of these worksheets on all of these videos in this series. I keep them all in a little folder just in case somebody is like, hey, that'd be cool if I could just, have that thing with all the answers on it. And yeah, sure. Shoot me an email. My email is in the description below next to the thing that says, hey, do you need tutoring? Because if you need tutoring, I'll give you your first lesson for free. I offer that to everyone. Obviously, you can only do the first lesson for free because, everybody's got to make a living somehow. But, the first lesson should be free because, you need to see if it's a good fit. And if it's not a good fit, then you can find somebody else if you're looking for a tutor. All right. So that is it. I'm going to fast forward on the scrolling here. It's going a little slow for my taste. And there's all the answers. And I hope this video has been helpful. If it has, of course, you can like, subscribe, do the bell for notifications, all that good stuff. And I'll see you in another video real soon.